Hi everyone, welcome back to Dragonfly Engineering. This episode is molding day, so this is the conclusion of a 4-part series where we machined this injection mold for these little plastic parts and assembled the mold in the last episode. And in this episode we're loading the mold onto the molding machine after a few minor final adjustments and measurements, and we will mold parts. So stay tuned and enjoy the show. Thanks. Okay, today is molding day. So the final thing that we're going to do is to drill our heater holes in both mold blocks, because we've got to heat the mold up to about 200 Fahrenheit or 100-ish C. So, and the cartridge heaters I use are 2 inches deep. So let's go ahead and drill these holes. This is a I gotta tighten down the key. This is a 9.4 millimeter drill, close to 3/8. I think the cartridge heaters are designed for a 3/8 hole, except they make them too loose so that it'll always fit in a 3/8 hole. So I've actually had to reduce the diameter of these drill bits a little bit, but the next empirical drill size is too tight. So anyway, I found this 9.4 millimeter drill, which seems to work pretty good. It gives a nice tight fit to the aluminum mold block. So we're going to drill this down 2 inches. There we go. And then the opposite corner, so we can get good heat distribution. You also want to make sure you're not drilling into any features inside of your mold. Okay, let me get the other mold half. Okay, here's the other side. Same process. Making sure not to drill into anything important. So we'll put this temperature sensor spot basically symmetric on the other side of the block. About that deep. It's about 1/2 inch deep. Okay, once I find the final bolt, because I'm sure there's one around here, then we can load this mold up on the press and start making parts. Injection molding press, that is. All right, so I got the A side of the mold over here on some 1, 2, 3 blocks on the inspection granite. So this is the surface that connects with the platen of the molding machine. So we're going to set that. This alignment ring doesn't really matter because it goes through a 110 millimeter ring in the molding machine. So this surface is irrelevant and was the original stock. So we're actually going to measure the machine surface. I've got this depth gauge here on the granite table. I usually like to keep it within 1/1000th of an inch or 25 microns. And it looks like we are good. I gotta come around this side so you can't see the dial, but yeah, we're right within 1/1000th. So we're set on this one. Now the other half of the mold is a little more flaky. I think it's due to the used nature of the of the riser blocks. But if we measure the height here, then we got some problems that need to be worked out. So first, I'm going to check out this surface, which doesn't actually contribute to the stack of the mold because this is relieved so that the stripper plate is the leading edge. And we've got 3/1000ths run out across that side of the mold. So if we flip around, we're 0 across this way, but we are 3/1000 out this direction as well. So I think one of these blocks is taller than the other. Then if we look at our stripper plate, which doesn't have the springs installed yet, so it's not compression seated. In fact, I should probably look at clearing out the inside of it. But anyway, at the moment, yeah, it's way off. So I believe I need to actually seat this plate correctly and make sure there's no particles underneath it, and then remeasure. Okay, I got the stripper plate off of the mold, and yeah, I had basically some chips from when I drilled the heater spots, or the heater holes. I got a few chips that got underneath the stripper plate. So we'll clean this guy out real good, and I do need to probably shave off 3/1000 of this riser block down here, and then I'll go ahead and put the springs in. Well, I can do one more measurement. Oh, actually, you can see our ejector pins poking up through. That's kind of cool to see. Anyway, so we will fix up the riser block, reinstall with the springs, and then I think we'll be ready to go. I'll do one final height measurement, and then we'll load this guy onto the molding machine. All right, we're over at the injection molding machine. This is a Boy injection molding machine. It's a German company, and it's a 25-ton press. So this clamp here generates 25 tons to hold the mold shut while we inject plastic into it. Now our tiny little parts don't really need that much force, so I'm going to back off the clamping force. And I've started loading the mold just because the camera angles wouldn't work out with me heaving this mold into place. But what I did is I put this board down across the bottom to protect me from dropping the mold through to the floor if I didn't do something right. And then here in the back, I've attached these two bolts, this bolt right here, and this bolt down here, through the platen of the molding machine and into the corresponding threaded holes that we machined into the A side of the mold. Same as these holes back here. You can see that 3/8 bolt. So I also added the 1/2-13 rod, which screws into the ejector plate, this guy right here. And this is a thermal insulator, as well as this guy is also a thermal insulator. So I'm going to insert the heater cartridge, which is basically just a 2-inch resistor in a steel tube. That white stuff is thermal grease, and we just kind of shove the cartridge into the heater hole right there. There's a similar one on the other side. This sensor goes into this hole. It looks like I need to thread. I'll actually need to thread that hole. Half of my sensors are threaded and the other half aren't. All right, so what we're going to do now, since I've screwed the mold into the A side of the clamp, we can pull this board out of here. And I will go ahead and, with the other camera, we will finish loading this mold. I have another series where I go into more detail about loading the mold into the molding machine and running the molding machine. So if you want to check that out, I can put a link in the description below. But we're just going to move forward with loading this mold and focus on how the mold behaves or how our parts eject and mold on this new mold. Okay, so without further ado, I will switch to probably time lapse and then finish loading this mold up. Alright, so I loaded the mold and I closed the clamp in setup mode and then taught the molding machine what the height of the mold is. I also attached the ejector plate to the ejector system and pulled the ejector plate back and then taught the system, the molding machine, where the ejector plate should retract to. I also advanced the injection unit to touch the nozzle on the A side of the mold. That's the nozzle where the plastic enters into the mold, and taught the machine where the nozzle position is. So what we need to do now is I need to get the heaters started. So I need to tap a hole or tap the hole that we drilled, screw the sensor in, and then start the temperature sensors. And I've already started to heat the plastic in the barrel, and the machine right now is heating its oil up. That's why the motor is running. It's actually squirting its oil through a little orifice inside of its hydraulic system to heat the oil. So we're getting close, and I will tap this hole and be right back so we can start heating the mold up to about 100 degrees C. Okay, so I tapped this hole, and when you're setting this stuff up, you want to make sure that wires, especially high voltage heater wires or sensors, don't get trapped between the mold when it closes, because it'll definitely cut it off or smash it into an infinitely small piece of wire and short out and blow a breaker and other problems. So keep that in mind. Let me tighten this guy down a little bit, and then we can get our mold heater started. It's a little rough going in. There we go. Okay. Now we can get temperature feedback on our temperature controller. It's also a good idea to look for smoke when you first turn on your heater, you know, because maybe you forgot to stick a heater in and it's sitting there getting red hot and burning something. Yeah, so I see a little smoke rising over there. Let me take a look on the back, see what the situation is. Okay, so my heater is sticking out a little too far, so the back of that heater is heating up. So let me turn off the heater, and I gotta use some pliers to push that in more. The switch down there. So that was a good example of a smoke check. Yeah, these heaters will get orange hot basically until they short out or burn themselves out. So you need to have them completely embedded in metal so that they don't get too hot. Because I believe they're 250 watts of, or maybe these are 400 watts of heater power. So you definitely need to sink that heat away. Okay, let me close this guy up. And we are looking good. Okay, so the plastic we're going to use is COP plastic, which is this clear granular plastic here you can see inside of this container. So it's kind of like, it looks like acrylic or something. But anyway, it's an interesting plastic. It's used a lot for plastic lenses and things. And we're going to dump this COP into the hopper. And I had this plastic tube here because this particular grade of plastic doesn't like oxygen. So we're actually going to pipe some nitrogen from a nitrogen bottle down into the bottom of our hopper, and that will purge the oxygen out of our hopper, such that this clear plastic doesn't start to turn amber from exposure to oxygen when it's melted. So we'll pour this stuff in to the hopper like so. I'm holding this tube so that it's down in the bottom of the hopper. And then we'll put the lid on. And we are ready to go. Let me go and turn the nitrogen on. All right, so here's our nitrogen bottle, and we'll just turn the regulator on. Oh, actually, we'll just turn the regulator should be set to a very small amount. So there we're at 2,000 psi, or what is the other reading? Well, I'm in the US, so 2,000 psi. And we're just going to crack this regulator a little bit because we just want a small purge. So there I can just hear some gas shooting through. There's no indication on the pressure or the output pressure regulator because there's no back pressure. So right now there's just a trickle of nitrogen filling the hopper out there on the molding machine and purging the oxygen out of the hopper. So I'm going to auger in fresh plastic. You can see this is the depiction of the auger. So we pulled in 11 millimeters of melted plastic into the injection unit, which is this guy right here. You can see the hot nozzle tip ready to go into the mold in the front of the molding machine. Now I'm going to back the mold out. You can see how the stripper plate moved forward by a few millimeters as it opened. And let's go ahead and see what happens. So we're going to try our first injection. Oh, I gotta back the screw up. There's an annoying new feature with this machine that you gotta hit an extra button every time. Okay, here we go. So the mold closed. Let me show you what's going on the screen. We injected to 5.3 millimeters, which is a good number. You don't want the injection to go to 0 because then you got no plastic to pressurize in the mold. It's just a metal on metal. You know, the injection nozzle bottoms out and you're not pressurizing plastic. Okay, let's see if we can open and eject. Look at that. We ejected. I have too much of a retention on the ejector pin in the middle, the sprue ejector pin. Let me eject that forward. And so it's going to stick, unfortunately, but I machined in a little undercut, so I'm going to have to reduce the strength of that undercut. But let's see what our first parts look like. So there it is. That is our first part. And the other part, boy, I need to clean this bucket out, is this one. So success. Okay, I think I'm going to mold a few more of these and then we can take a look under the microscope after I clean this bucket out. All right, but let's go ahead and fire it up again. Oh, right now I got the ejector pins forward, but this molding machine knows that if I'm telling it to mold another shot, it's going to pull those pins back before it closes the mold. So you can see how it pulled it back, and then we close. You see there's some pushback from the stripper plate springs, so the molding machine had to hesitate a second. You set the pressure on the clamp to sense for obstruction, so it sensed that spring was there and it slowed down. I can increase the clamp pressure before it actually locks up and does the 15 tons of pressure. But it's also tricky because if you do have a part that's stuck, then you can damage your mold or smash the part in there. So having mold springs is tricky because you lose the sensitivity that the machine has to see if there's a part stuck between the two mold halves. But I think I'm going to be stuck pulling this ejector pin out until I can, or the center sprue, until I can reduce the grab on that center sprue ejector. So we're going to be stuck in kind of quasi-manual mode for a while because I got to get first articles delivered. So when I pull the mold back off, I'll reduce the aggressiveness of this kind of undercut grab feature on the sprue. But yeah, here's two more parts, looking good. Okay, we got the mold running in fully automatic mode. I fixed a couple of minor alignment problems, and I took a file to that sprue pulling ejector pin, and now the little tree of parts ejects with the sprue. So that's cool. That's the part ejecting. I have to teach the robot to cut the sprues off, and then here's the control interface. Probably get some funny video rastering. So, yeah, looking good. And here's the part again. So our cycle time is 25 seconds. I think I can reduce that. Well, thanks for watching.